Hello YouTube, and welcome back to my channel. Today we're just going to be doing another one of those random little kit builds of something that I found that was interesting at my local electronics shop. And what it is it's this little USB powered flashing LED Christmas tree. I can already hear the comments below. Oh my god, it's not even Halloween yet, why are you doing Christmas? Rawr! Yeah, I can already hear you. Well, the fact is, they did not have a USB-powered jack-o'-lantern at my electronics shop, but they did have a USB-powered Christmas tree. Now, this is going to actually be particularly interesting because this build is using surface mount technology. So it's going to be really super tiny little components that are going to require some special soldering techniques, which is why I purchased this particular kit, because I wanted to show off how you manage to actually do surface mount soldering by hand, because this is actually supposed to be done by machine. But you can, if you have sufficient dexterity, do these by hand. So I'm just going to get everything set up here. And I need to reach behind me. There we go. And let's grab some tweezers. There we go. So, surface mount. These are ridiculously little tiny components. We'll just start with the surface mount USB plug here, because that's how it powers itself. So that's a fairly bog standard USB plug there, only it's meant for surface mount instead of through hole. So you can see, now this is what you would expect with a standard through-hole component. It's a nice long lead, and you poke it through the board as far as you want, and you have lots of room to solder, and you glop lots of solder onto it, and then you trim off the lead when you're done. Well, you don't have the luxury of doing that with surface mount technology, because if you look at the bottom of this, you see all these little itty-bitty tiny pins. Well, those are the things that you actually have to solder. And you can't really afford to put tons of solder on them because you'll just short them onto the pin next to them. So you have to be a little bit judicious with your soldering techniques. Now, these things are crazy tiny components. So I'm just going to open up these little, we call these ammo strips, because what happens is these actually get fed into a machine. And the machine peels off this upper plastic coating here that I'm struggling with. Here we go. It peels it off automatically for each component, so it just pulls those back. And then it comes along with a little suction cup, or a little vacuum tube or something like that, and it picks up the component, and it brings it over, and it plops it down onto the appropriate spot on the board. And of course the board will have already had solder paste applied to it. It's basically just solder dust that's suspended in, I believe, some sort of organic base to make it a paste, because I remember when I worked at Fleetwood, which is this place in Michigan, we had to keep the solder paste in the refrigerator, otherwise it would spoil. I never asked, and I really should have asked why we had to keep it in the refrigerator. That's actually a question that I have never gone any further into asking, so I might have to quickly do some Google Foo before the end of the video here and get us an answer on why you keep solder paste in the fridge. I figure it has to do something with there being a temperature sensitivity of the components that make it into a paste. So these little black boxes here, those are capacitors, and they're actually electrolytic capacitors, or, well, they are at least polarized capacitors. I wouldn't quote me for sure if they're electrolytics. But they are polarized capacitors, and we're used to seeing those in a state more like something that I can't find on my desk at the moment. Oh, come on, I've got to have an electrolytic capacitor somewhere around here, or at least a polarized capacitor. Okay, well, apparently I don't have a capacitor of the type... Oh, here we go. In fact, these are electrolytic capacitors. So this is your basic polarized capacitor with a negative terminal there. You know, so, and these are even 470 microfarads capacitors, which these are 470 microfarad capacitors. But these are 470 microfarads at 35 volt capacitors. These are 475 microfarads at 16 volts. So they've got half the voltage rating, but they're, even for only having half the voltage rating, they are much, much, much smaller. So that's an interesting thing. And these little guys here, these are transistors. These little tiny packages. I could look up the data sheet on these, but that's a W1P transistor. It's going to be part of the circuitry that causes the LEDs to flash. Oh, that's interesting, actually. They didn't include a circuit diagram. So it'll be interesting to reverse engineer this device and see what it looks like. Let's see. Now these resistors are 1003. Yeah, these are resistors, these little black boxes here. So I'm just gonna fight with this plastic some more. Come on. Of course, because the machine does this automatically, but I have to do it by hand. So those are 1003, which, if memory serves, means that that's 100 followed by 3 zeros. So these are 100 k ohm resistors. These little itty tiny bitty black dots are 100 k ohm resistors. And then this little bit of ammo belt here, or ammo strip, is full of 4700 resistors, which is a 47 and a 0 followed by 0 zeros. So these are 470 ohm resistors. My assumption is that they are probably part of the current limiting circuitry for the LEDs in the circuit. I did not peel that off at all well, but whatever, it doesn't matter. So we'll just pour those out. Thankfully, they give you far more of these little tiny components than you actually need, because they are quite well aware that you will probably screw up and either lose one or mess one up by being a little too overexcited with your soldering, or any number of situations. So, and then these are LEDs. These little tiny things. Whoops. Speaking of messing up and scattering them everywhere. So these little white dots that are now scattered all over my desk are LEDs. And I'm not entirely too sure how to identify polarity on these guys. It says here the dots go on the side with the thicker line. Okay, so there are the little dots there. Anyway, so there we have some surface mount components, these little tiny, tiny, tiny things. And then we have a switch, which is the through-hole component, and then we have a battery clip, because you can also power it off of a CR2032 battery, so you can plug that in. And then we've got a little diode that does not actually seem to serve any electrical purpose, because it's grounded to itself on the ground plane of the USB connector. So I think the diode here is actually just there to act as a stand for the Christmas tree. Alrighty, so on to the technique of manually soldering surface mount components onto a board. This is actually remarkably challenging. So we're going to start with one of the resistors. We'll go with R1. Where's R1? Here it is. And what you do is you put a little dab, come on, little dab of solder on the board there, and then I'm actually going to be fairly generous with the use of flux here, so I'm actually going to put a little dab of flux there. Then you take your tweezers, and let's see, R1 is supposed to be one of the 1003s, so we're just going to grab one of these 1003s very carefully and put it onto the board here. And we're going to just nudge it over so that it's touching that blob of solder. And we're going to grab the soldering iron here and just remelt that solder like so, and it sucks the resistor right over onto it. And then we'll take the other side here and just dab some more solder onto that side. And that's how you solder a surface mount component. You always, I'll show you again with R2, which is right here. A little solder onto the pad. I'm actually going to dab a little bit of flux on. And then we'll grab another one of the 1003s, because that's what that resistor is. And we'll lay it down. You don't even have to lay it down particularly straight, because when you melt the solder and it grabs the little surface mount chip there, it just sucks it right into place, right where it belongs. I actually did much better with that soldering job than I did over here. There are great big balls of solder on that, whereas there's just a nice even flow of solder on that resistor. So there we go on that one. Just for fun, I'll do one of the LEDs, because they're slightly different in size and shape. So we'll do LD1, which is just here. A little dab of solder on the pads. Or not solder, a little dab of flux on the pads. A little dab of solder. And then this is the challenging part, because you have to figure out the polarity of the LED correctly. And we'll nudge it over onto the pad where the solder is, and just let the solder draw the LED over on its own. You have to actually be really careful when soldering surface mount LEDs, because they are quite sensitive to temperature. So you don't want to expose them to heat for too long, or you might end up damaging them. I put way too much solder on that one, it was being difficult. So anyway, rather than, I'll do one of the transistors, because that's actually an even more complicated process because you've got the three legs of the transistor. So we're going to just put a little dab of flux on each of those pads again. I really need to invest in some flux cleaner because this board is going to be super sticky by the time I'm done working with it. And we're going to put a little dab of solder on the base of the transistor here. There we go. And then we'll just try to flip it over because it's upside down right now. I grab that, place it on the board, nudge it over, and then flow the solder onto it. And then you have to kind of judiciously keep heat on the transistor while aligning it onto the pads. And then once it's aligned, you just give it a quick dab of solder on each of its legs. And there you have soldering a transistor on. You have to be really quick with the transistors because they are very sensitive to heat. And if you cook them, it's not going to work. And the last thing is the capacitors, which are actually fairly simple because they are a much larger component. So we'll just smear a little flux on as usual, put a little blob of solder on the plus pad, and the interesting thing about surface mount capacitors is that their plus is actually the stripe, whereas normally the negative is the stripe. So we'll position that appropriately so that the stripe is facing, oops, oh, I almost soldered that on backwards. There we go. We'll flip that around and we'll just let the solder suck it over onto the pad, and then solder the other side on. So there we go. Now I'm going to switch over, get onto there. I'm going to switch over to time-lapse mode and finish up this soldering because it'll be really boring for you to watch if I do the whole thing live. So I will see you in a few minutes when I get to the other side of this soldering job. See you in a bit. Alright, and we're back. The time-lapse footage got cut a little bit short. Well, I don't know how much short it got cut because I don't know when the iPad ran out of memory, but it ran out of memory and thusly stopped recording. So we're going to continue working on it now. I've finished all of the surface mount components now. You probably saw at least a good portion of the process before my iPad stopped recording. But anyway, we're just going to flip this over real quick and apply a little flux to the switch leads here. Really need to get a flux pen so I can stop using this goop. But I'll just throw some solder onto that pin. Come on. Which is being very difficult about flowing on. Huh. There we we go. Okay, finally. There's that. There's that one. Okay. And next is the USB plug, which is going to require quite a bit of solder. But we're just going to goop it up with some flux there. And then we're going to place the USB plug very carefully because it's actually self-aligning because they were smart and they put pins on it so that it would align on the board without fuss. So that's a good thing. So we'll just quickly flow a bunch of solder onto the ground legs here. Maybe. Come on. You have to turn up the soldering iron here a little bit because it's not having a happy time trying to flow solder onto the leg of the USB. There's a lot of thermal mass there that you have to overcome when soldering the leg of the USB plug onto the board here. It can be a bit challenging with a small soldering iron like this. So we're just going to finish quickly flowing some solder onto those legs to hold it on. And then we're going to very carefully, and you're not going to be able to really see what I'm doing here, but we need to apply solder very carefully to the legs. Ow, that's very warm. Of the USB pin there. And as I was worried about earlier, I accidentally flowed way too much solder on, and now I've shorted all of the pins together. And that is a thing that can happen when you're working with surface mount. So I'm going to have to go in there with my solder braid here and suck off the extra. Hopefully I can suck off enough to remove the solder bridges, but leave enough for the device to actually still make a connection. Let's see if I actually accomplished that. It looks like I actually did manage to do that. Okay. Then we're going to take this little diode here and kind of artfully curve the leads around. He says, as he completely not artfully does it, but well, that's good enough. And we'll just run that through here real quick and solder it on like so, and like so. And that is ostensibly a stand for the Christmas tree, so you can stand it up. Not overly certain if that's how effective that'll be, but whatever, we'll see what happens. And then last but not least is to solder on the battery clip, which I'm probably going to burn myself doing. Or not. Okay, so that's nice and level. Just tap that one more time with the soldering. Ow, 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 ow. That was warm. Okay. So now that we've got one of the pins down, we don't have to touch it anymore to solder the rest of the pins down. So there we have it. And now it's complete. Now, I think I should have some, yes, here we go, some button cells here from a Swedish company that is not sponsoring me. And we'll get the battery there. And we'll just slip the battery in there. Look at that. Flashy lights. That's not overly exciting, but hey, it's a flashing Christmas tree. So there you have it. That was a little bit of an exploration into working with surface mount components when you don't actually have a surface mount machine to place the components for you. So hopefully you enjoyed watching the video. If you liked it, let me know in the comments below. Give me a like and a subscribe. Share it with your friends. Do that thing you do when you like videos. And I will see you in the next video. Bye-bye.